All right, let's talk about what's on tap. So tap is VMware's Tanzu application platform, and my colleagues Ryan Baxter and Greg Meyer and I are going to take the next 40 minutes to tell you all about it. I'm going to provide a broad introduction, and then Greg and Ryan are going to give you a hands-on view. Before getting into tap specifically, I want to start with this question. What is an internal developer platform? Because that's ultimately what we're striving for. This term has gotten a lot of attention recently, and it might be relatively new, but whether we realize it or not at the time, we've been on this journey for a couple of decades now, heading towards internal developer platforms. Every step in the evolution of providing really any form of computing capabilities as a service is rooted in this idea of empowering a user with self-driven, autonomous experience. Infrastructure as a service, for example, enabled people to provision core systems without the expertise or the burden of maintaining the underlying infrastructure. You could eventually create an entire data center just using self-service software APIs. When these capabilities were exposed publicly with a pay-as-you-go model, public clouds were born. And suddenly, anyone could create a mini data center from the comfort of their home with relative ease. This leap forward was monumental, and it democratized, or it played a key role in democratizing the software industry. If you're interested, in fact, I highly recommend Stephen O'Grady's book, The New Kingmakers, for a really inspiring account of this period in history. Now, while this shift facilitated and accelerated software development and innovation, infrastructure as a service and public clouds as a whole really addressed operational needs. There is a wide gap between developer needs and operational needs, and we called the effort to simplify and bridge this gap DevOps. In the early 2010s, we saw significant efforts to approach the problem from a developer perspective. Platforms like Heroku and Cloud Foundry radically simplified that deployment experience to a simple CF push or git push Heroku that was cleverly summarized in this fun haiku. Here is my code, run it on the cloud, I do not care how. Now, these platforms were, and they continue to be, hugely successful in improving the developer and the DevOps experiences, but the ecosystem of integrations around them grew slowly. It wasn't quite easy enough to quickly expand the selection of services for developers to use. A few years later, Docker and Kubernetes turned the industry on its head. Right? So Docker, as you know, catalyzed the use of containers as that standard unit of work. And this accelerated adoption of microservice architectures and cloud native development practices. And then Kubernetes basically redefined the APIs and the architectural patterns for self-healing declarative deployments, and it ignited widespread adoption of GitOps. These extremely successful models enabled the spectacular cloud-native ecosystem that we have today, and that is so often illustrated in the jam-packed CNCF landscape. But just like infrastructure as a service, containerization and Kubernetes most directly impact operational concerns. There's still a substantial gap between Kubernetes and developer needs. So what is this gap, right? What do developers need? And what should we be looking for in an internal developer platform? So remember, the trend has always been towards simplified, self-driven autonomy, right? So that is key. Now, when we talk about autonomy, to a large extent, we mean the ability to easily and independently create, update, or destroy a particular thing in a way that meets certain standards and expectations. For a developer, that thing is an application and its direct dependencies, right? Usually some sort of data service. And the standards and expectations include things like reliability, security, resiliency, scalability. So to achieve this, all underlying layers need to be automated and integrated with one another. So this includes any workflows that test, build, and scan code, configure the desired state, and then make that state a reality. Ideally, a developer should only need to commit code to a Git repository, and then that action should trigger the entire process behind the scenes, right? No need to adopt operational skills or even switch context to operational tasks, right? Just move on to your next code iteration or your next feature branch. And Kubernetes is a game changer in enabling us to compose this kind of automated application platform. And this is the first step towards a true developer platform. But it's not enough to pave a path to production or simplify the use of Kubernetes. Developers, for example, need feedback as well, right? Did my app pass testing and security checks? Which environments is it running in? How much traffic is it getting? Or even what's happening at the network layer when I see erratic latency in my application. So a developer platform should consolidate observability feeds into one intuitive portal, right? Developers shouldn't need to go hunting this information down across disparate sources. But it's also not all about what's running. Developers need to manage all kinds of other information like documentation, APIs, source code location, ownership, and other things like that. This information can get messy very quickly, messy and overwhelming, and the lack of it can exacerbate duplication and tech debt across an organization. So it's also about a developer's relationship to their own body of work and their relationship with other teams across the organization. So a developer platform should enable developers to share, discover, and even contribute to information about all of the internal applications at their disposal. This can have a profound impact on developer efficiency, productivity, and collaboration, both for onboarding and ongoing development. And finally, a developer platform is an opportunity for education and enablement. A developer platform, it should be the go-to place for developers to discover the preferred approach within their organization, right? The so-called golden path to any number of developer concerns. This can be through templates for new applications, readily available mechanisms for publishing documentation or APIs, a default path to production, pre-configured solutions for observability, and more. For each challenge, a primary working solution at the ready with sensible defaults, codifying the patterns and conventions that we want to encourage within our organizations. I'm sure most of you have heard the phrase, make the right thing the easy thing. Internal developer platforms help us make the right thing the obvious thing. Now, the only sane way to do this is through a single pane of glass, right? A coherent and consolidated user interface. To this end, there is an exciting technology that has already stimulated an active community and ecosystem of its own. I'm referring to Baxter, which is a framework and a platform for creating developer-focused user interfaces. This technology was open sourced and contributed to the CNCF by Spotify in 2020, and it is revolutionizing the internal developer platform space. So Backstage provides the framework for a single pane of glass UI experience, and it enables us to add the capabilities that we want to provide developers using custom or ecosystem plugins. So what is VMware bringing to the table? So VMware provides a wealth of expertise in all of the layers that are necessary to underpin a comprehensive developer platform, and it pulls these together in the Tanzu application platform, right? What we call TAP. So it leans on Kubernetes, Backstage, and other open source technologies, and it simplifies and enriches the developer, DevOps, and operational experiences with an intuitive but powerful golden path that you can use out of the box on any compliant Kubernetes cluster. So as a developer, for example, you can use application templates to jumpstart application development. You can also test small code changes quickly and easily in a real environment directly from your IDE. You can track your application on its path to production, and you can verify all of the safety and configuration features that are built into the default supply chain. You can explore your app's running resources and access logs and configuration. You can get a live view of the performance and health of your application at runtime. You can share, discover, and test APIs. You can explore the vast array of internal applications and resources in your organization with a full view of their source code location, documentation, security analysis, etc. You can quickly understand entire systems with visuals of interrelationships between applications. And then where your case might detour from the golden path, TAP allows for pluggability and customization. So that being said, I hope that you are as excited as I am to see TAP in action. So next, Ryan is going to walk you through a day in the life of a Spring Boot developer using TAP. And in particular, he's going to showcase the integration with your IDE and the rapid deployment to Kubernetes so you can test as you code. And then Greg is going to showcase the web UI and highlight some of the ways that TAP supports a broad range of needs for applications and organizations. So with that, I'm going to turn it over to Ryan.
Thanks, Cora, for that great introduction to TAP. Hey everyone, my name is Ryan Baxter, and I'm a software engineer on the Spring Cloud team here at VMware. And today I'm going to take you through how to basically build a very simple Spring Boot application and then use all the fantastic tools that TAP has to offer in order to easily deploy that application to Kubernetes. So to get started, since I'm playing the role as a developer here, I have my VS Code IDE up and running, and I already have my Tanzu developer tools installed into this IDE. So we're going to get started by actually using one of those tools right off the bat, and that's the Tanzu App Accelerator. So the Tanzu App Accelerator provides a whole bunch of basically simple projects that you can use to get started to see how to use all the great features that TAP has to provide. We're going to choose one of the more basic accelerators here, and that's the TAP project configuration. This is basically going to create a whole bunch of files, or a couple of files that we're going to use that to easily deploy the application to TAP. So we only have to fill out a few basic fields here. And we're going to call this app the availability app, right? And so basically what this app is going to do is tell us what restaurants are available for us to eat at, right? So very basic, the name of the restaurant, and then whether it's available for us to eat at or not. So that's why it's called the availability application. So we're just going to fill out these two fields here. All the other defaults are fine for now. So we're just going to click continue and generate project. It's going to ask me where I want to put this project. I'm going to choose this folder here, and I'm going to accept that. And then if we go back to my Explorer here, we can see we now have some files that the accelerator has generated. So we're going to come back to these files a little bit later on and take a look at some of them. But first I want to basically stub out the rest of our project, all the source code that we need for our Spring Boot application. And of course, to do that, we're going to use the Spring Initializer. So we have that built into the IDE here. So I'm just going to go to Spring Initializer inside of VS Code. We're going to use the latest and greatest Spring Boot version 3.0. Choose Java. That group ID is okay. And then what are we going to call this? We're going to call it the availability app, like I already said. We'll choose jar. We'll choose Java 17. And then what dependencies do we want? So we're going to use Spring Web. We're going to use Actuator. We're going to use DevTools. We're also going to, so we're going to persist data within this application to a SQL database. So we're going to use Spring Data JDBC. We're also going to, as far as the database, we'll use H2 for local development purposes. And then when we deploy the application to TAP, we're actually going to use MySQL. So we'll add the MySQL driver as well. So with those 6 dependencies, we can actually generate the project. And again, it's going to ask me where to put it. So I'll put it here, and I'll click continue. And now if I refresh this here, we will see the rest of our project. So I'm actually at this point going to restart VS Code, only because sometimes it doesn't recognize that we now have a Java project. And to avoid any kind of complications further on in the demo, it's easier for it to just restart, and it'll pick up that it's a Java project, and we can move on with our lives here. So to get started, what I'm going to do is actually go to source main resources. And in here, I'm going to add a new file as well. And so we're going to create a schema.sql file. This is obviously going to create our table in the database. So the table is very basic. It just has the ID, the name, and then whether the restaurant is available or not. And then we're going to add a data.sql file as well. And that's to just insert some data for demo purposes. So we're going to insert just 2 restaurants here. Everyone likes pizza, so we'll say Domino's is the name of the restaurant, and they do have availability. And then the other thing that everyone really likes is Mexican food, at least I do. And so we'll say Chipotle. They unfortunately do not have availability. So we got some data, we got our table. We're also going to open up our application.properties file here. And we're going to add 2 properties here just for demonstration purposes. So we're going to say Spring SQL init mode, and we're going to set that to be always. Basically, always initialize the database, and then we're going to say Spring SQL init continue on error true. And this is basically, again, this is not something you would do in real life. It's just purely for demo purposes. We always want the database to be initialized, and we also always want the app to start even if there is some type of error. So with that, we can actually get going and building the actual business logic in our application. So we're going to open up our main class file here. And the first thing we do is going to create a record for the availability in the database. So we're going to say record availability, and that's going to have an @ID, integer ID, and it's going to have a string name and a Boolean available. And the next thing we'll do is create an interface called availability repo, and it's going to extend CRUD repository, and that's going to be parameterized by availability and integer. And then we can create a REST controller here. And so we'll say, I didn't mean to do that. Class availability controller. All right. Import this for me. Try this again. REST control. There we go. Okay. And then this REST controller is going to have a private variable called availability repo in it. And in the constructor, we are going to take in the availability repo, and it will say this dot repo equals repo. All right, and now down here we're going to create a @get mapping, and at the root here we'll say it's going to return a iterable of availability, and we'll call it index. All right. And then this is going to return repo.findAll. All right, so we got our class basically set up here. So let's test it out. We're just going to run it locally. And I'll move that up here. While it's starting, I'm going to create 2 other terminal windows that we'll use later on. So looks the app started, so we can test it out and say HP:8080. And we get back Domino's and Chipotle has false and Domino's has true. So that has worked out as we planned, which is great for the demo. The next thing, what we want to do here is take this application and get it running on Kubernetes with TAP. So we're going to jump back to some of those files that the accelerator generated. So the first one we're going to take a look at is this workload.yaml. And this YAML file is actually all we really need to get the app running on tap, which is really great because if you're familiar with deploying applications to Kubernetes, just vanilla Kubernetes, you know that you generally have to write a whole bunch more YAML than this. Which for me as a developer, I'm not really a huge fan of writing a lot of YAML. So this small amount of YAML is much more attractive to me than what I would normally have to write. And in fact, you'll see this bottom piece here is trying to point at a Git repo. We're not there yet. We don't have our code in a Git repo. We just started out doing development. Everything's in our IDE, and I actually want to run the code within my IDE. So I actually don't even want this code here. But I do need to tell TAP that we need to use Java 17 to build our app. So I need to add this environment variable here that tells TAP to do that, or else by default we use Java 11. We want to use Java 17. And I also mentioned that we're going to want to use MySQL as a database when we're running on tap. So if you're familiar with service bindings from Cloud Foundry, we can do something very similar to binding to a service on Cloud Foundry on tap. So we can bind to the MySQL database on tap. And I actually have asked my operator, my Kubernetes operator, to provision me a MySQL database that I can use for development purposes. And we can see that he or she has already done that. We have this availability MySQL instance that's running for me on Kubernetes. And I want to bind to that MySQL instance. So I can just add this snippet of YAML here, which says I want to bind to this availability MySQL instance. And what that's going to do is give me the username, the password, the URL, all the information I really need to connect to that database. And through the magic of service bindings, it's going to also add a property source to my application when it starts on tap with all the correct Spring JDBC, Spring Data JDBC properties set in order for my application to use that database. So that takes care of manipulating the workload.yaml. And again, because I'm a developer living inside my IDE here, I want to just run this thing on tap from my IDE. And that's what this tilt file is down here. So tilt is an open source tool that you can go ahead and check out if you want. It's really useful for Kubernetes purposes, but we have integrated with that tool with our Tanzu developer tools. And so this is the tilt file, which basically sets up everything we need to run the application from my IDE here. The only thing I actually need to change is where I'm going to place the source code from my IDE so that TAP can build and run this thing. And so I have a container registry out on Google Cloud that I'm going to use. So that's going to be where we're going to place that code. But other than that, all the defaults here are actually okay for me. So with that, I can just right click on this tilt file and you see we have the options, this Tanzu Live Update Start. I'm going to select that and it's going to start this, but it's actually going to ask me one more thing because it wants to have permissions to run this on my cluster. I'm going to tell it that it's okay by adding this one line to my tilt file and saving that. And now this is where all the magic actually happens here. So right now, the Tanzu developer tools are taking the source code that's here within my IDE. It's uploading it to TAP and then taking that source code and putting it in a container repo that I had mentioned a second ago. And now it's really going to do all the hard work for me. So normally, if I was to do this on my own, I'd have to, build a container, put that container somewhere in a container registry, make sure my Kubernetes cluster has access to that container registry, create all that YAML that you normally have to write, and then deploy that to Kubernetes. And I also need to keep in mind about all the best practices that are involved in running a Spring Boot application on Kubernetes. So things like configuring liveliness and readiness probes, making sure that my actuator is running on a separate port, and making sure I have things like graceful shutdown set up so that if a request is being handled by my application and a termination request comes into the application, that it doesn't just automatically shut down in the middle of handling that request. Like all these things that are important, but I probably, if I'm not really an expert in Kubernetes, probably may not be familiar with how to set up properly. And it takes a long time, and there's lots of Googling of documentation and stuff like that. So Tap actually does a whole bunch of all the stuff that I just mentioned for me, and builds everything and does all that. And with the magic of Tilt, also, it's going to do some port forwarding for me so that I can, you can see this right here, I can hit port 8080 just as if the application was running locally on my machine, and it's going to forward the request off to the container running in my Tap cluster, which is running in AWS. And it also is going to do, you notice it said Tanzu live update. So that means if I make changes to my source code, it's going to push the updated class files off to Tap and restart the application without me having to go through this process every time I want to make a change and see what that change actually looks like in the running application. So this is all provided to me by Tap, and it's all part of what we call the supply chain in Tap. So if we take a look just quickly, you can see the supply chain that's actually running here in my Tap instance and where we're at in that process. And so hopefully you can see here the application is now just starting here. So there's the output for the Spring app starting. So what we're going to do here is test to make sure it actually works. That's probably a good idea, right? So we're going to go back here. Oops. And say HTTP:8080. We should get the same result back as we did before, which we do, which is really cool. So I mentioned that live update piece. So if I go back to my main class file here, I'm going to change this. I don't want to return an iterable. I want to return a string instead. And so I'm going to use something called stream support .stream. And so we're going to take this here and paste it here. And we'll say .splitterator. And then we are going to map this. And the mapping function is just going to actually return the name of the restaurant. And then we're going to collect everything. And we're going to say collectors.join. And we're going to join on just comma space. So we now should just get a comma separated list of names back. And so if I select this terminal window again, and then I save this, you can see the class files being updated, the application being restarted. And now if I hit this endpoint, hopefully my terminal works, there we go. We get back just the separated list. So that's the live update piece. And the last thing I want to show you real quickly is that we are actually using this database. So I'm going to try and port forward here to my SQL instance so we can connect to it. And if I go to my database tool here and check out the availability table, you can see the data that we had already added. We're going to add another row. So we'll say the ID is 3, and the other food that everyone likes is burgers. So we're going to say Burger King. Not that Burger King has the best burgers, but you get the point. And then they do have availability. So I'm going to save that. I'm going to go ahead back here and hit my endpoint again, and we see that Burger King has been returned back. So that is the basics of how to get a basic Spring Boot application up and running on Kubernetes using Tap. You can tell that if you've done that in the past, which is a vanilla Kubernetes instance, that it's much simpler to do. And from a developer perspective, all the integrated tooling within the IDE from our Tanzu developer tools makes iterating and building and deploying and basically building out that application much simpler. It removes some of the stuff I don't really care too much about as a developer, as far as like best practices around building or running an application on Kubernetes, how to build a container, where it goes, all that stuff, all taken care of for me. I can just focus on writing my code and building the best application that I can possibly be, and kind of remove all the stuff that's not as important to me as a developer. But there's a whole bunch of other stuff that TAP can do. And to tell us more about that, I'm going to hand it over to Greg.
All right, thanks, Ryan. That was an awesome demo. Quick intro. My name is Greg Meyer, and I'm an application architect with the TAP Developer Experience team. And I'm going to take you through some more advanced uses of TAP and from an app perspective, as well as some other tools that TAP provides for developers. So that great use case that Ryan just took us through, that works really well for getting our hands dirty. But we all know that real world applications really are quite a bit more complex than just single microservices with like a single REST endpoint. Your applications are likely going to consist of several modules using different data services like Redis or MongoDB, and then they're going to communicate with each other over a range of different protocols like REST or an async messaging system like RabbitMQ. So with that, I'm going to introduce you to a reference application called Where for Dinner. And this started shipping as an out-of-the-box sample accelerator in TAP 1.3, and it's recently got enhanced with even more features with TAP 1.4. So this is actually a nice segue from Ryan's demo. As this dining app, it actually has that availability API as a small part of this larger application. So Where for Dinner. This is a highly configurable reference architecture that incorporates really a wide range of TAP features that are must-haves for developing and deploying contemporary apps. And I'll briefly talk about some of those. First of all, it breaks everything into multiple microservices. We just see a lot of these demos out there today. They just kind of throw everything together in a single monolithic app. But generally, real applications, they create separate domain-bound microservices as well as other services that perform specific business functions. Next, and what I think is actually one of the most important features is service binding. It's so much Ryan talked about this. I'm going to cover it again. And he went through this with the MySQL instance. So as he had said, if you are familiar with like service binding in Cloud Foundry, the concept is pretty much the same. In TAP, you specify what you want your application to connect to with what's called a service claim. And then the platform does present those credentials over to your application. And there's some magic then that happens behind the scenes, which we won't go into. Ryan actually covered a little more detail of that. But if you're familiar with like what the CFENV library does in Cloud Foundry, it's very, very similar. Next, there is an option of implementing security using the TAP SSO component. This gives us the capability to consume auth services using OIDC compliant identity providers, and this does work for both front end and back end components. We can also see here in the app that there's an aspect of doing asynchronous messaging through this eventing channel. By default, this app uses RabbitMQ, but as of TAP 1.4, it has a configuration option, or we can switch this over to using cloud events and Knative eventing. The really cool part about that is that since this uses Spring Cloud functions underneath the covers, there are actually zero code changes that occur when we switch from RabbitMQ and back over to cloud events. And also with the cloud eventing model, this app also demonstrates some scale to zero features where these targeted BizLogic apps, they only get spun up when there's actually work for them to do. And then lastly in here, we could see this API gateway, which is implemented with the Spring Cloud Gateway. And we're not done with this. There are other features that haven't been implemented yet. So definitely keep your eyes open for additional features of this reference architecture as we start moving on to newer versions of TAP. So now we're going to switch over to some of the other productivity features. We're going to jump over to the TAP GUI, which is built on Backstage, and Cora talked about that a little bit earlier. And this is more or less a web portal into the TAP application, which includes some really cool tools. Excuse me. The first one of these we're going to look at is the App Accelerator, which Ryan talked about this a little bit inside of the IDE. It's also available inside of the TAP GUI as well. So to me, App Accelerators really have two main functions. Ryan went through the first of these, which was kind of getting you started with some samples. The second of these is that you actually can create your own accelerators that can serve as templates for creating projects that are specific to the needs of your organization. Accelerators have a lot of great templating functionality. So you could very easily build an accelerator that generates a starter project that is specific for your architecture and your policies. And if you want to enforce specific things for your applications. So for instance, you could go and create a web application template with like a POM file that includes specific dependencies and versions that you want your project to utilize. So there's literally an unlimited amount of different options that we can have. So this is really a great place to explore for creating some of your own templates. Next, we're going to talk about the supply chain, which Ryan briefly introduced you to when he built his app. So here you can see all the workloads that I've deployed in my cluster. And if I click on one of these, and let's go pick the availability one, since this is the one we were talking about earlier. And here we can see all the different steps that happen all the way from when the source code actually got pulled into the cluster, all the way down to the step where we actually deployed this app out to our cluster. Each one of these steps, you can click on them. There's a lot of great information inside of each one of these. So one that I want to look at here is the source tester. This would be like where your J units end up getting run. So let's say that there was a failure inside of this and you need to figure, hey, what happened to my app when it tried to test it? You can actually click on all these different runs. And here I can see the log files and I can do my analysis, or I can do it online, or I could actually download it to try to figure out what happened. Another one is that I think is really cool is the source and image scanners. And this is really where TAP goes in and does like CVE scanning and reporting. So let's go look at image scanning here. If I click on that, if I scroll down here, now I can get a list of all the CVEs that got detected and reported, as well as some other information about those. If I click on a particular CVE, I can get even more information, which that's also going to include like the name of all the apps where everything got detected. So this particular one, I can actually see it's kind of all over the place. So I should probably go take a look at that. This is all part of a module called the security analysis, which if we go to the top level view of that, that's going to show me a high level categorization of all the CVEs that got detected in all the apps across my cluster. I can also define policies and see which applications are either compliant or that are in violation of specific policies. So this is kind of a really cool tool for like your chief security officers. And then finally, we're going to go look at some observability. Cora talked about being able to observe apps. That's very important. We're going to use modules called Runtime Resources and Live View. And I can get to those by going up to what's called the TAP catalog, which for the sake of time, I'm not really going to go through. Other than to mention, this is kind of our entry point to go get to those runtime resources. So let's go down here and find that availability app that we're talking about. And over here, we've got our runtime resources. And what I see here now is kind of all the resources that it took to build my app, everything from the deployment all the way down to the pod. And the pod's really where all the interesting stuff happens. So we can get some filters here so we can go find our pod. Oh, there it is. So now I can see even more information about my pod where my app is running. The first thing here that we can see is viewing the pod logs. This is where I can actually see all of the logs that are getting dumped out by my application. So if I need to do any type of debugging there. I've also got some other filters here, like where I want to start looking at the logs. I can even change the log levels. You can see by default here, everything is at the info level. So let's go down or back here to the pod details and look at the live view. And here we can get even a whole bunch more of information about what's going on with our app. So if I drop this down here, I can see a category or categories of all the other information that's available. So let's just like look at the health check. This is actually getting pulled in from the actuator. So all of my health checks look really good. Another one that I find really useful is the memory. So this is just another tool here. I can look at the memory of usage of what's going on with my app in real time, and it'll just kind of keep tracking that as it goes along. And there's also a whole bunch of other great insights, from other categories that we saw here, which we won't go through any of those. But anyway, that's a quick look at the application live view. And there's even a lot other more modules out here, like the API discovery. Cora talked about that a little bit. But for the sake of time, we're not going to be able to go through those, even though this is a really cool feature. So anyway, that's a quick peek at some of the productivity features that inside of the TAP GUI. And with that, I'm going to go ahead and land this plane. But before I go, I do want to give a list of some other great resources that you could go take a look at for further reading and research. Want to thank everybody for spending your time watching today. Big thanks over to Ryan and Cora for that great demo and introduction. And everybody enjoy the rest of the sessions. Thank you.